Before going over this problem, it's very important to understand the setup. Now, there's many ways you can set up this problem, but the most conventional way and possibly the easiest way to set it up is by making the 0 point in the y-axis the point when the antelope leaves the ground. That means when the antelope is crouching, ready to jump up, we call that a negative of the 0. So he's below the 0 point. So in this case, this problem is broken up into two pieces. The first piece is when the antelope is crouched down and is in the process of accelerating to the point in which he leaves the ground. So we'll call this with the appropriate variables or parameter names. Y naught is then going to be when he's crouched down. T naught is when he's at that crouch position. V naught is when he's crouched down accordingly. And Y naught or A naught is when he is accelerating upward. After he's done accelerating and is about to leave the ground, he is now in position Y1. He is going at a velocity V1, and the time at that point is T1. Okay, so this whole process of him accelerating to get off the ground is the first part of the problem. The second part of the problem is when he has just left the ground and is going to his highest point. Now, in that case, we call his initial condition consistent with his final condition in the first part. So Y1, V1, and T1. But then we will look at his final position after the acceleration due to gravity has taken a toll on him. We will call his highest point Y2, V2, and it will be achieved at time T2. At this point, or at this part of the problem, acceleration is just due to gravity, which is negative 9.8 meters per second squared. So take into effect these 3 points of interest, the naught, the 1, and the 2 subscript point of interests, and the 2 accelerations that are happening in between the transition period. So we'll call these, we'll say that this is a 2-step problem accordingly. That being the case, if you want to know the height of the antelope, we were looking for Y2. Here is the list of knowns that was given to us in the page that I just showed you with the picture. And I put it in the same format so it's easy and familiar to look at. Okay, so in order to do this, what I like to do is I like to go after our main goal. Our main goal is the overall height when the antelope is at its highest point. What I noticed though is that there is no time except this time equals 0. So the problem here is that we don't have any other time indicators besides the one we just made up in the very beginning. So the best course of action is to use a kinematic equation that doesn't involve time. The best one I could think of, and seems like the only one that is available in this case, is this one right here. And I'm going to use the appropriate subscripts to determine what I need to find. So it looks like I want to find Y2. I'm going to write down the equation for the second part of the problem, and that is when the antelope is already leaving the ground and is about to reach his final height. Okay, so notice that the velocity at the very end, when he's at this highest point, squared is equal to the velocity as he is just about to leave the ground, squared, plus 2 times his acceleration pushing down on him due to gravity, times the difference in his position from when he left the ground to his highest point. Obviously, now we need to find his highest point, Y2. Based on the variables we are given in the known box, Y1 is going to be 0 because that's what we indicate as 0. We're making that when he leaves the ground. At his highest point, which is V sub 2, that's also going to be 0 because he's already done jumping up. So he's about to come back down. Okay, this seems to be good enough. We know what A1 Y is. That's simply negative G. We need to find Y2. We already know what these zeros are zeros here. And I don't think we know v1y. That's the velocity of him right when he left the ground. So that's the problem. We don't have this. In an equation, we need to have every other parameter except the one that we're trying to find. Otherwise, we can't use that equation. Um, but however, for us, what we're going to do is we're going to do a side quest in order to make this happen. So let's go ahead and do a side quest to find this out. Side quest. And the side quest is going to involve using the first part of the problem. And that's when he's crouched down and his accelerating up to jump off the ground. That's the first part of the problem that we're going to use now. So actually what I'm going to do is I'm going to use the same equation, but now for the first part of the problem. So that's going to be v1y squared equals to v naught y squared plus 2a naught y times y1 minus y naught. Let's go ahead and look at this real quickly. Y naught is when he's crouched on the very bottom of the ground. Y1 is right when he leaves the ground. A naught y is how he's accelerating. V naught y is actually going to be 0 because that's when he's about to accelerate as he's trying to jump. And then v1y is what we're trying to find. So I'm just going to circle this lightly, and we're going to try to use that and plug it into this equation to finally find our answer. So let's go ahead and find this out using what we know here. What I'm going to do is I'm going to try to keep it as a variable and in variable form so that it's easier to plug in later on and we can do the calculations at the end. Like I said before, and based on what we see up here, y1 is 0. We already know what y naught is. We know what a naught y is. So it looks like this equation is good to go. We can plug this into this equation. We can go ahead and do the math and find out our final answer from here. And so this is why I like to try to get to the goal equation first, and then if I need to, get side quest equations to find out what I need to achieve my goal. That's why I start with the last equation, the final equation first, and then kind of go backwards in time and try to find out its pieces that it's missing. Okay, so v1y squared is now going to equal to 2a naught y times negative y naught. Going and taking the square root of both sides, you get v1y equaling to the square root of negative 2a naught y naught. Now, before you start getting worried that there's a negative in the square root sign, keep in mind that y naught is a negative number. So it's actually going to cancel out and it's not going to be an imaginary number as one might think. So now that we have a equation for v1y, let's go ahead and plug it into our main equation. Our main equation is now, with all the zeros put in, is now going to be 0 equaling to this, oops, this is a squared. So I'm going to say negative 2a naught y naught plus 2a1y y2. It's a mouthful. Okay, so now with this, we're going to go ahead and solve for y2 finally. Okay, doing a little bit of algebra. y2 is going to equal to 2a naught y naught divided by 2a1y. All right, the 2's are going to cancel out, leaving us with a naught y naught divided by a1y. Now let's plug in the numbers. A naught y is 35 meters per second squared. That's how the antelope accelerated as he was starting the jump. Y naught is negative 0.7, and A1y is negative 9.8 meters per second squared. Once you plug in the numbers, and let me go ahead and just plug in the numbers so we can get that out of the way. Once we plug in the numbers, put it into our calculator, we get a nice, pretty 2.5 meters. And that's your final answer. That is the Y2 that we are trying to look for when the antelope has reached his highest position.